Hello everyone, I hope you're doing well. Today, the subject of my lecture is more about grammar. In the previous lectures, we have already discussed transformation generated grammar or the transformation rules, and we also discussed this topic when we were taking classes on the campus, right? So I'm just touching this topic further, right, for the sake of better understanding and for the sake of more simple understanding. In the last chapter, you have been introduced to transformation genetic grammar. In this chapter, let us try to understand more grammar. Let us take up the simplest definition of grammar. Grammar की definition है यहाँ पे. It is a device which can create a well-formed sentence in a human language. Human language does mean human language, right? It does not include the sounds or the fonts produced by animals or the birds or other things, other living things. So you can say, what is grammar? It is a device which can create a well-formed sentences. So first of all, we can focus on this thing, that is, it is a device. Then we can focus on this thing, that is, which can create a well-formed sentences, not only sentences, right? So only sentences will not make a language. It will not be audible or comprehensible thing, right? So in order to define a language, you must say that it create a well-formed sentences in a human language. So now let us take an example. The girl followed the boy. It is a very simple example. So we will see the rules, transformation rules. We'll apply some transformation rules on this sentence. We will check the base level or the structure of this sentence initially. Now let us forget the phrase structure rules we read earlier and try to guess how this sentence was created. The simplest guess or hypothesis is that words have been placed one after the other. So our simplest guess is that this sentence has been made by putting the words one after the other. That is, we put the plus girl plus followed and so on in a linear fashion. So this is a linear model. First of all, the it might be a new term for you. You can say that this is a linear model because words come one after other in a straight line, right? So this method, this model is known as linear because words follow one another in a linear or in a straight line. It can also be called a chain model, right? Why chain model? Since words are connected to each other like links in a chain. So you can call this chain model as well because words are connected to each other like links in a chain. It is a static model since nothing can move from one place to another. So another name you have got for this, that is static model. Why? Because nothing can move from one place to another, right? There are fixed places for fixed words, for the arranged words. It is also called a finite state grammar since it is static and therefore cannot change state. So another name we have got for this, that is finite state grammar. Why finite state grammar? Because it is static and it does not change its state. This simple model of grammar can be created by imagining the flow of an electric current from one point to another, creating a sentence as it goes, for example. So this model can also be imagined, or you can say thought by thinking of an electric current from one point to another. Let's take an example. Here we have got the sentence in a different manner. We have made the loops of of the words here. The girl followed the boy. This is the same sentence. We have just given the titles to the words, and we have drawn some loops, right? The dotted lines show the loops of current. So A, B, C, D, E for the different words at different position. Now, if you start the current at B from here and stop it at C, if you start the current from B and stop it at C, so what will the sentence be? It will be like this: girl followed, because the sentence from B to C is this one. Similarly, if you want to create more than one sentence, you will have to create loops so that the current can be passed through one circuit or the other as you like. So if you want to create more sentences, or if you want to make the sentence complex or compound, you will have to create more loops so that the current can pass, so that the current can be passed through the circuits, through the loops. Let us try to generate the sentences given below by this kind of model. So let us try some other sentences here. First one is the girl followed the boy, then the boy followed the girl, the boys followed the girls, etc. So what will the models be? the models will be as follows. Like the girl followed the boy. In this way, you are putting the it is kind of the same sentence we have earlier discussed. The girl followed the boy here. So the girl followed the boy at the same, so same words at the same position here. The boy followed the girl. We have given the same title A B C D E to the words at different position, right? The boys follow the girls here. So again, the same model, almost the same model, because the role of the word is the same in all these sentences 3, 4, 5. But it would be extremely uneconomical to use a new model for every sentence, right? Let us see what is common in these models and try to make only one model which will produce all these sentences. So, of course, trying new models for each sentence is not economical thing, right? It is kind of an uneconomical sentence or uneconomical use of words, right? So let us try to make a device or engineer a model which can be used for all the sentences, all the examples aforementioned. So here we have the model: the boy, boys, girl, in the same circuit, followed the girl, girls, boy. So we have got this models, and this model can be used for all the above sentences 3, 4, 5, right? 1, 2, 3, 4, 5. More complex sentences would require even more loops, and the grammar would not be efficient because it would create sentences we do not want. Of course, when you will encounter with more complex sentences, so you will require more loops, and the grammar would not suffice there. So grammar would not be sufficient enough, or grammar would not be able to 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 take care of all those rules, or to cope with all those rules, right? So, for example, if we say the boys followed the boy, number six sentence, or the seventh, the boy followed the boy. Here the grammar here the sentences are becoming more complex, right? The girl follows the girl, etc. So the grammar cannot cope up with all these sentences, right? So we have to devise some other models as well. Here is another model for this. We have already discussed linear model, and you also named it differently. You also said that linear model links. You also call it chain model. You also call it static model, etc. Here we have linear models. Because of these defects, Chomsky abandoned this linear model of grammar in syntactic structures 1957. So, of course, there are some defects in these models, because these this model cannot cope up with more complex examples, right? So that's why Chomsky abandoned this linear model, and he discussed and he abandoned this linear model and told us about these defects in syntactic structure, which is the work produced by Chomsky in 1957. As the title indicates, he concentrated on syntax, that is the arrangement of words in a sentence, and stated that this arrangement was subject to rules. So just instead of just drawing new models or new diagrams or loops for each sentence, for even more complex sentences, he just focused on, concentrated on syntax. What is syntax? That is the arrangement of words in a sentence or a phrase or clause. And stated that this arrangement was subject to rules. So he also stated that this arrangement, this syntax is subject to rules, right? We have already looked at phrase structures, PS rules, which he said generated basic or deep structures. Of course, we have already discussed this PS rule or phrase structure rules. So he said, which he said generated basic or deep structures. So according to Chomsky, this phrase structure generated basic or deep structures. Of course, this phrase structure is used in making, generating basic or deep structures. These deep structures were then subjected to change by transformational rules, T rules, which created surface structures. So consequently, what happened, or subsequently what happened? So these deep structures are once again transformed, right? They are once again subject to change by transformation rules or T rules. Then these then when we apply transformation rules on deep structures, then we generate or create surface structures. In Aspects of Theory of Syntax, a work produced by Chomsky in 1965, Chomsky changed his grammatical model to look something like this. So he changed his grammatical model in 1965 and gave us something new like this. First of all, he thought that we have base component. Then from base component, we have PS rules. We apply phrase structure rules. Then we also have lexicon, that is the words in the dictionary. And then from these things, we develop a deep structure. Then we apply transformation rules or T rules. And by applying T rules, we get surface structure, and from surface structure, we get semantic component and phonological component. And this thing has been described here as well. To put it very simply, the idea is that the base contains here in this diagram, the base contains PS, phrase structure rules, which create a kind of skeleton for the syntactic categories NP, and so on to fit in one another or under the other. So idea is that this base component, this base thing, it contains PS rules, that is phrase structure rules, and this phrase structure rules create a kind of skeleton for the syntactic categories, right? So the syntax, we get noun phrases, verb phrases, prepositional phrases, etc. We get them from this from base structures. Sorry, from phrase structures, right? So and where are the phrase? Where do the phrase structure lie? They lie in the base components, right? So we can say that this base component contains phrase structure rules, and from phrase structure rules actually generate these NP, VP, etc. Then comes the lexicon, which is a dictionary or collection of words. So every word is specified. Then after, of course, after this phrase structure rules, we have lexicon, because every word is specified in such a way that only that word can be fitted into the PS rules correctly. So we cannot use all the words in one place. Of course, one word can be used at one position. Not all the words, not so many words can be used at one position, right? So first of all, we have base component, and in the base component, we have PS rules, and then we have lexicon. And then from these things, what happens? This creates a kind of deep structure. We get a deep structure from these things. Now what happens after getting a deep structure? We apply T rules are applied. We apply T rules on this deep structure, which change the sentence so that it comes to in a chain form to the surface level. Now it takes on meaning, and of course by applying T rules we get the surface structure or the surface level. Now what happens? Now it takes on meaning. Of course, when you get the surface structure, it takes on meaning, and it is the semantic component which gives it that meaning. First of all, from surface structure, we get the semantic component which gives it meaning. It can be spoken or written in symbols which refer to spoken sounds, which is the phonological component. And it can also be spoken, it can also be written in symbol, etc. So we call them, and the component which is used for speaking or for written symbols, etc. That is known as phonological component. This is a simple model of TG, transformation grammar, which is presented in Chomsky's books mentioned above. The theory behind this model is slightly more complex because it has been simplified here to make it understandable. This theory is called the standard theory. As you can see, the PS rules can generate sentences in a fixed order. If there were the only way of generating sentences, we would need an infinite number of PS rules to generate an infinite number of sentences. So we know that this phrase structure rules can generate sentences in a fixed order, of course. And if there are only way of generating sentences, if this were the only way of generating sentences, we would need an infinite number of PS rules to generate an infinite number of sentences. So of course, if we consider, if we imagine, or if you suppose that if this PS rule is the only rule we have for generating sentences, so we would know, what would we need? We would need an infinite number of PS rules to generate an infinite number of sentences. That would not be feasible, of course. Thus, according to Chomsky, only the simplest sentences are generated through PS rules. So yes, Chomsky made it easy for us, or easier for us, because of course we cannot generate an infinite number of PS rules to generate an infinite number of sentences. So Chomsky made it easier for us, and what did he say, or what he gave us? He said that the simplest sentences are generated through PS rules. So according to him, the simplest sentences are generated through this PS rule or phrase structure rule. Even these kernel sentences are generated at a deep level. So according to him, even the kernel sentences or simple sentences are generated at a deep level. These are then changed through movements of constituents. Of course, then we apply T rules, and then these are changed through movements of constituents, through movements of words, of course. This movement transforms sentences into different kind of sentences. This is why they are called transformation rules. To illustrate transformation through movement, consider the following example. The boy followed the dog. This is the first, this is the example number 9, and we will apply the T rules here. The following sentence means the same thing. The dog was followed by the boy. So here we have the kernel sentence, the base, or the sentence at deep level, right? The base sentence or the simple sentence. Then we apply the T rules, and we apply the transformation rules here, and we got a new sentence with the same meaning, of course, but with different words. We added was and by in the sentence here. These second sentence 10 must be transform form of a base sentence 9 at the deep level. So of course this sentence number 10 is a transform form of the basic sentence 9 at the deep level. Some transformation rules, T rules have produced a second passive structure. Let us number the NPs and VPs here. So of course the boy is the noun phrase. We said noun phrase number 1, followed is verb phrase. So verb phrase is number 2. So the dog again is noun phrase. So we said noun phrase 2 is equal to 3. Overall we have 3 phrases in this sentence, and we have 2 noun phrases in this sentence and 1 verb phrase. So the structure is the 1 plus 2 plus 3, because we have already named it 1, like 2 and 3, etc. So this structure is 1 plus 2 plus 3, and this structure is called the structural, and this method is called, the structure is called structural description, right? And this, the second structure, the structure of example number 10. What did we do here? We just change the position. First of all, we have 1 plus 2 plus 3. Then what will we do? We change the position of this, and we put the dog at the position of 1, and the boy at number 3, right? So we also added was and by in sentence number 10, and we also you can say change the position. So this is the structure for another sentence, that is sentence number 3. First of all, structural description is 1 plus 2 plus 3. So this second structural change, second method is known as structural change. When we change the structure, in this what will we do? 3 plus was plus 2 plus by plus 1. So you can see this here. So the dog is put at number 3. Here it was at number 3, so here it is number 1, but we will write it like this: at 3, then we added was, then the number 2, of course, then 1. So this is called structural change. So as you can see, this tree rule has moved constituent and inserted was and by in this case. This is the same point which I have already discussed. Grammar as a machine which generates sentences. To sum up, you can imagine grammar as a machine or a device for creating sentences. It is in the mind of the speaker and represents his or her knowledge of the language. It contains rules for creating simple sentences at the deep level, which are then transformed by transformation rules into more complex sentences. So according to this paragraph, grammar is a machine or a device for creating sentences. And first of all, we create a sentence in the mind. Our sentence get created in the mind of speaker, and it represents the knowledge of the language of the speaker, right? And then what happens? Uh, of course, there are some rules for getting simple sentences at the deep level. Then we transform these sentences by transformation rules into more complex sentences. Like, right now, let us see what kind of arguments can be advanced in favor of their existence. One of these arguments, so of course we need some arguments to prove that why we create such sentences at deep level, why we create the sentence like I put the book on the table. Why didn't we say that I put the book? Why didn't we only say that I put the book only, right? Why did we say I put the book on the table like this, right? So we have some reasons behind this. One of these arguments that in some sentences movement seems to have occurred. That is, it appears that some constituents have been moved from their original places. Let us take an example. I put the book on the table. Now put is a verb which is followed by an NP. I put, it is followed by an NP, that is noun phrase, then it is followed by a PP, that is prepositional phrase. This NP is followed by a PP, beginning with in, on, inside, outside, etc. and so on. That is something which tells us where the thing has been put. So yes, this PP tells us that where the book has been placed or put. In other words, for a verb like put, the lexicon must specify what constituents follow it. So of course the verbs like put the lexicon, it must specify what constituents follow it. So put is verb, it is followed by NP and PP. If PP and V and NP do not follow this put, there would be an odd sentence. We will not get a complete meaning, or it would be considered as an ill-formed sentence. So this is written here. If you omit either the NP or the PP after put, we will produce a grammatical ill-formed sentence. For example, if you simply say I put on the table, if you omit the book or the noun phrase, so we do not get the meaning from this sentence. And again, if you say that I put the book, and here we uh, omitted that on the table, that is PP, again we are not getting the clear meaning, right? So but it's not always the case, right? In this sentence, of course, it's the case we cannot omit PP or NP, but in some cases we can remove it. But in that case, there is a different transformation rule. We are just putting what before that sentence, right? In this case, we say that what did I put? What did I put on the table? Yes, we still have the complete meaning. We are posing a question, right? We do not need NP here after put, right? We can simply say what did I put on the table. I do not need to say what did I put the book on the table. It will be an informed sentence if I put NP after this put, right? In this sentence, put is not followed by an NP. However, we have just stated that put is subcategorized in the lexicon as being a verb followed by an NP and a PP. Of course, put can be subcategorized. First of all, it can be followed by an NP and a PP. Then these subcategorization facts are constants. Of course, these facts are constant. But thus, what has happened in that the NP after put has moved away from its original position at some stage. Of course, we can still remove this NP after put at some stage, and because we have some different transformation, we have applied some different transformation rules on the sentence. In that case, we have already put what before there, right? That's why we do not need NP after put here. So thus we assume that there is a deep level at which it was there, and that T rules have moved it away. So we assume that at deep level there was an NP after put. At deep level, there was an NP after put, right? But T rules or transformation rules, this T rule, we applied this rule here, T rules here, right? We put what in this sentence and we transform this sentence into a different structure, right? So what happened here? And this T rules, after applying this T rules, we have we NP have been moved away, right? But at the deep level, the writer, the Chomsky tells us that we had NP after put, but after applying T rules, we have moved it away. Some T rules also brings what to the beginning of the sentence. Of course, some transformation rules bring this what to the beginning of the sentence. In short, rules move parts of phrases from one place to another in sentence. We will try to understand this in more detail later. Yes, there are so many other examples in which we can apply transformation rules on phrases and sentences, clauses, etc. We will of course learn them in the in the in uh, in the later lecture as well, and you can also explore them on internet. We also discuss them in the class as well. Thank you very much for watching. If you have any question, do ask.